All right, while you get that on. Sorry.
This via HDMI 3.
Yeah. Otherwise, there's another one if you want to try that. Max sometimes people have an issue.
Here, USB-C into here.
That's USB-C.
Do you have HDMI coming out anywhere?
No, only this. But this apparently does still max out on occasion.
Sorry, my laptop here. I'm going to steal it.
That's your one there. Do you know any tricks to get this to work with a Mac?
Did you install the driver?
What driver?
It was emailed out to all the speakers. That could
From Mac OS. No,
Do you know who will know? I don't use them. Use proper operating systems.
Is there a driver in that email? Yeah, I'm downloading it now.
Thank you, Mr. Mac. Right, while we wait for Mac, asked to do it magic thing.
You can't
Good morning,
it. It
everyone.
looks like it's not.
Welcome to the badge track.
Even detecting it.
The
See if you
plan today, we've got
yeah.
Kyle and Kevin are going to be giving up talk about what they did in terms of designing the badge, some of the challenges they could do with it, and then there'll be about 30 minutes, and then there'll be an opportunity for those of you that want to stay, ask some more questions, do some tinkering, etc. They'll be around
You have Zoom.
for half an hour here, and the rest of the day
Just
there's a
explaining.
section upstairs.
This is,
Go and
yeah,
chat
this
to
is
them
my
about
bad.
the
No, it's all right.
hardware
No.
of the badge.
Downloading the Zoom.
So Kyle and Caleb are
It's
founding members
going
of
to
SolarSet.
download
where they
the
work on
into
a
zip file.
variety of very
Is it
interesting
I think
technology
it's downloading.
projects.
Yeah. So you can just extract it and then
And
I
they've
don't know why
been
it says easy.
recently,
Maybe it's
Carl been
That is a
involved in
package.
vulnerability management programs, a lot of the track simulation, and working with a diverse range of clients. And Caleb has a passion for integrating security into the whole product development lifecycle. And the whole area that we've heard about recently is sort of supply chain attacks. Baking your security in is becoming a really important thing to do. And we'll wait to, we've got some progress here, and we'll,
Right, yeah.
that's mine.
I lost my copy. Someone stole my copy.
Should we go?
No problem. There we are.
All right. Good
All
night,
right, thank you so much.
No worries.
You got it.
I figure out what screen. Just trying to figure out what screen it's presenting. Hold on. I've got multiple screens. It's
That one there is duplicated if you want to. Yes, that's the one that's on the.
okay. Yeah,
I can fill any empty space. I'll start talking about how you just make extraordinary badges all the time.
thanks.
Want me to?
No. It's kind of critical to be able to see.
Yeah, but I can
Okay.
help 3 seconds.
Why is it only showing that?
Can
Use actually out of whatever
you-
actual ones we have. And just have it.
Where was that? Is this-
Is it one of those situations where you create the new thing and bring it over?
But where is that? Here?
That's the map.
Let me select the settings.
Yeah.
Okay, great. I'll just have everyone look at my stuff. That's fine.
Amazing.
All right. Sorry about that. Due to technical difficulties, we will do this talk extremely fast. All right. I have been informed by somewhat trustworthy Norwegians that this says what I wanted to say, but making a sykt badge, meaning hopefully it's not the interpretation of like an actual physically sick, something that's cool, and hopefully it is also cool. So we're just going to talk quickly about, the badge that we made and how we did it, steps that we went through, if anyone wants to make a badge, and then also why it's cool and why we think people should make a badge. Taking all these?
Yeah, no, so as Caleb said, today is gonna be pretty informal. Like if those of you that were just in the keynote, he was very direct in his message today. We just want to give context to the badge, something for you guys to look at, to look into, and then we'll be around later today to figure out how to do the challenges and hack into it and really just understand where everyone is in their story, because what we're gonna get in today is making this badge and just hardware hacking in general. Hardware hacking is still one of those topics in security, which is fairly newer. It's getting more popularity. So people are at different stages. And so for us to give a 15-minute talk on the intricacies of creating this badge is probably a little audacious. So we're going to try to give you some context and then hopefully some questions from there. So as Caleb said, introduce ourselves, give you the timeline, the worldview or the universe in which we use to create this badge and which we use to develop the badge. The prototyping that went into it, the firmware that's on it, and then how we scaled up and built it for 150 y'all. So.
It just stopped. Awesome.
Yeah, sick.
Building the badge was much easier than doing this
Yeah.
presentation. Looks like I lost internet connection.
I guess while we're doing that, everyone has their badge. I see a lot of them out. One thing that you will notice is that the batteries in it, it's gonna go quick. So find, there'll be extra batteries that we will have and others will have that, if you ever go down, like, I think mine's already been maxed out.
There's also a hardware switch on the right side if you want to preserve your battery, because it's running a Wi-Fi access point, which we'll talk about. Your hotspot on? Do you have internet access?
Have you tried turning it on and off? Join that.
There's a slide on that. Join that one. Or, yes. All right, we'll stick with this one for now.
Okay.
All right, we're gonna hammer through the rest of this real quick.
Yep.
So I think we're here. A little bit about us. My name is Caleb Davis, co-founder of SoloSec. I made this badge and have made a bunch of badges, but our day job is pen testing, specifically embedded systems. I have a background in electrical engineering. So that is a little bit about me.
Yeah,
Give a quick
no,
intro.
I think the takeaway here is that, SoloSec is not a badge making company, we're a pen testing company, right? This is a side hobby project and something that allows us to come to Norway and other fun countries, and so we're at DEF CON every year, making badges for Biohacking Village. And so, yeah, you'll see us around some of these cons with other custom badges. All right, so why does this matter? Why are we here? Why did you guys decide to spend time this morning to come to our talk in addition to filling up your coffee after that keynote? So the idea is to start to give individuals this development expertise. I find in security, it's very easy to silo yourself into one area of that universe that I was trying to describe and build. But understanding the stage one, that root, the manufacturing, the development piece is so important in understanding why things happen further down in the manufacturing process. The impact, obviously, that's something, again, why the embedded is becoming so hot these days, is because understanding how you can make changes in the beginning of the process that will affect downstream as well. The manufacturing awareness, whenever we give a recommendation of, look to see who's manufacturing the product that we hack, I think we get eye rolls, but that's where you have to start. And then the last is fun. We love this. We love figuring out TTFs, figuring out challenges and teaching people how to solder and how to do fun stuff that seems really dangerous. But this is awesome to us. So we look forward to chatting with you. All right, create the badge timeline. So really, people get surprised by this, but we usually start with a blank slate. When we talk to B, when we start engaging in conversation with individuals who want to run a B-size or any conference really and create a badge, it's a whiteboard. It's what do you want? What is your end goal in mind? And you see, because everyone's been to conferences and they've seen sick badges and they've been like, oh man, like I don't even know how we would create something like this. Like what, but also you want to make something meaningful. You want something where people get it and they remember it. They're just not going to throw it to the side when they get home because they want to. So a duck, hopefully a duck's meaningful for you. Prototyping. So we take this idea, sometimes it's grandiose in nature, and we have to cut it down. We can say, hey, okay, that was a really cool idea, but this is the budget. So what do we actually want to do? So we start prototyping, start throwing ideas, part selection from the manufacturers we work with. And then the fun part, and Caleb's going to elaborate on this a little bit later, is like the hardware and firmware development. Because it's one thing to make something that looks visibly cool, but then something that's actually practically useful and can teach you things as well. And so we go through that, we build out the pilots, and this is a 6-month plus process. So we've been looking forward to this day and looking forward to this badge for a while. And then issue remediation, which is always a fun part of this conversation, where you'll see pictures of us in the car on the way from Oslo, soldering in the back and putting these things together. And then, just scaling up and making sure that we have enough, and in this case, a couple hundred. So, all right. Brainstorming, like I said, we try to build this platform where there's universal scope to give someone the idea and the creativity to get something that's meaningful to them. But it really starts 6 months before these conferences. So these conversations were happening the end of last year. Yeah, so it's been a long time coming. And then the cost is always the kicker, right? And so, yeah.
All right, I can take this one.
Sure.
So I'll briefly run through this, but some of the main drivers for us, and it's really a driver for all badges, but for us specifically, looking at the functionality of the device, we want it to be cool, something you can play with, not just a light show. So keep that in mind. I guess we hadn't really talked about it too much, but there are, I think, 9 flags associated with this badge that are in a variety of different locations. I'll talk about the core in a second, but it runs an access point. So you can connect to your own badge, hopefully not everyone else's badge, but I mean, you can do what you want. But connect to it. It's got an access point website, so you can connect and go find all the flags. So we like it where you can modify the badge, obviously. Availability, this is less of a problem now, but it's been a problem historically where, these Raspberry Pi Pico Ws is what we're getting. Sometimes they're just not available for whatever reason. So that's a main driver. Power consumption, your 2 AA batteries should last as long as you don't hack it and like run these LEDs consistently. But that's a big driver for some of these conferences, especially DEF CON or Black Hat, these longer conferences. You don't want someone carrying around a car battery with them. Audience familiarity. This thing's running MicroPython. So if someone connects, and this is kind of a hint if you want to hack your badge, if you connect like a micro USB cable, it's running like a R shell, REPL type environment. So you can connect and look at Python code, and it's very simple. Everyone can understand it. So that's a big driver for us. Ease of use. Once again, all these things are kind of plug and play. Cost, main driver. I mean, there's really nothing too cost prohibitive with this. I think the Raspberry Pi is probably the main thing. And then flexibility. The Raspberry Pi itself has way more I/O than we use. We just use a couple different pins that I'm not going to talk about because those are some of the challenges. But it has a ton of I/O. So if you want to build out some crazy mod to this, you could. All right. So the initial badge, like we talked about previously, V, who's I think Weaver of Chaos was the title she wanted us to use. But she came to us with this design, which is, I'm told, is the crest for Christensen. I don't know if anyone can confirm that or not, but this was kind of where we started. So I think we've come a long way since then. But this is kind of where it starts. We just talk about this idea, this random picture, and then kind of a little bit of functionality, and then we just build around that and iterate consistently. And this is what we ended up with. I was also told that Norwegians love ducks. I don't know if that's a real thing or not. I'm not sure why we went with ducks, but we did. So this is the hardware prototype that I'll get into a little bit more. I'll quickly breeze through this as well. Stop by. We're going to be upstairs all day. So stop by if you're actually interested in building a badge or building, some electrical components. But key component selections, the main thing, right? Like I said, the Raspberry Pi Pico W was the main driver for us. And then from there, it's getting into, what kind of power rails do we need? What are the other major components? In this case, it's really LEDs in the Raspberry Pi. In bigger boards, those are major drivers that can impact the entire, selection process. From there, it's kind of laying out the schematic, what's connected to what, which interfaces are there. Looking at the footprint. Footprint is basically, if anyone's doesn't have a EE background, how it's oriented on the board. So if you look, each one has, some pads that are connected to different traces, and those have a different footprint. So you need a specific footprint for a specific component, and it impacts how you lay out your board. PCB layout's the next step. So just arranging the components, and this is honestly one of the most fun parts because basically you put all your components out on the board, you see kind of where they need to connect to each other, and you're literally just connecting the dots. So it's almost therapeutic. Remaining component selection. This is a lot of times these passive components, so like resistors, capacitors, inductors, things like that are a little easier to find and don't matter as much. That's when this can come into play. And the reason I like doing it like that is because with a more densely laid out board, it's easier to kind of just get your main parts out there and then fill in the gaps later on. Design rule check. If anyone's done a hardware design before, this is kind of the bane of your existence. Basically, it throws a bunch of errors and says, hey, you can't do this. It'll blow up the board and you have to go change a bunch of stuff. And in my case, ignore a bunch of stuff. Fabrication. We do these all with a third party. I don't know, in Norway, I don't know what's the best. If y'all can't tell, we're from America, Texas specifically. But so we use PCBWay in China. And then assembly and testing, we get a lot of them and just do some rapid iterations on testing. All right, briefly go through this. We use KiCad. There's a ton of EDA solutions. KiCad is open source and works good enough for these purposes. iCircuit, once again, I'm on Mac OS, which killed us this morning, but I use that for circuit simulation, which in this case is not a lot. Schematic design, briefly run through this. We've got a Raspberry Pi. We've got a bunch of LEDs. We've got, what is that? A tag connect that's not actually on there. This is just a power rectification circuit. So it takes the battery. This is all basic. You can get this from, you can just get that from the component website when I'm looking at what voltage rail I want. So stepping up 3 to 5. This is a switching circuit. These LEDs pull a ton of current just sitting there off. So what we do is we actually trigger a different voltage rail. So you can see that enable, if anyone can read that, enable VLED. So there's actually a pin that triggers to enable that voltage rail so that we can hopefully preserve the battery life, but we'll see how that goes. Board layout. This is what the two-dimensional board layout looks like. So basically it's just a bunch of layers. I've got what's called silk screen. I've got the custom board shape. I put all the LEDs on front, so it's pretty picture, and then basically everything on the backside. Something that's really nice if you're designing boards is you can do what's called power or ground planes. So the entire top surface of the board is power or the voltage rail for the LEDs. On the back plane, it's ground. So what that allows us to do is that when you lay out like the top, and you can kind of see it in here, this top up here, which is the voltage, instead of having to like run a trace and like connect it to a rail, it just fills in automatically to that top side, which saves you a ton of layout for running traces, and it makes it a lot cleaner. All right, 3D modeling, we can just kind of see how it looks in the EDA solution. Run through this firmware prototyping. That's one of the flags up there. Luckily, it's small enough that I don't think anyone can read it, but motivates you to go start looking for stuff. I got to get through this quickly. So firmware, write firmware, write it in small parts, and then put it all together. That's basically as easy as firmware is. Use ChatGPT. Visual Studio Code is what we use. It's got some good solutions. Like I said, MicroPython, CircuitPython is also super popular, and the Raspberry Pi Pico, very common platform. That's by design, so everyone can mess with it, because that is the ultimate goal. The software is extremely basic. It is just a loop that runs, and it's got a few different. It's got a thread that runs a different web server, and you can interact with the web server, make the LEDs do a bunch of stuff, and hack it a bunch of different ways. So I'd highly advise y'all doing that. All right, scaling up. We had to make a few of these by hand, and this is my daughter actually soldering these up, so I had to give her a shout out in this. But scaling up is kind of the bane of your existence. I would definitely advise if you have like a board house, they can assemble them and also fab them for you. It takes a little bit longer, but it's much better. I mean, she's a good solderer, so it worked out fine, but you don't want to be doing this for 150 badges. Yeah, what could possibly go wrong? All right. So I've got Mo Boards, Mo Problems, which is a rap song in the US. I don't know if it made it to Norway or not. But we actually didn't really have that much go wrong. My daughter, bless her heart, she did rip up a pad and I had to fix it. So I'm not sure who got this board, but it's out there somewhere. And basically, if you get a pad too hot, you can rip it and melt the adhesive that's holding it down. So we had to just patch that. Whoever got that is golden ticket winner. The other thing, would an idiot do that? I flashed these all with there's a access point configuration file. I flashed it with the wrong one that I was testing with and didn't realize until I was through all 150 boards. So on our way from Oslo to Christensen, we were flashing all of these boards in the car. So that was a fun time. Also watch out when using AI. I used AI to generate a lot of the slide deck here. And Abraham Lincoln had this quote that I don't think is actually accurate that it came up with. Yeah, I don't think he made any sick badges. Closing thoughts. All right. So hopefully, I know we ran through this very quickly. Hopefully you learned how we did this, a few helpful tools. Come talk to us upstairs if you're really interested, but I would highly encourage everyone to build a badge. It's fun, and there's a lot of things you can learn from it. That, I believe, is all we've got. Any?
Okay. Thank you very much. For those of you that want to change tracks, to go and watch the talk that's going to be starting shortly in the other one, you can change now if you want to get into the other venue. For anyone else, we've got another half hour set aside of badge tinkering. Go back and have some more Q&A. Maybe look at some of the design aspects a little bit larger. So if any of you are wanting to change tracks, now's the time to do it. Otherwise, we can go on, we'll just let people move and then we can carry on with some Q&A. That's good. Well done on speed run.
I'm going to hammer through that. Thank you, guys.
Thank you.
Thank you.
Yeah, I knew the keynote was gonna go long, and then
That was awesome. It was a good keynote, so I didn't want to leave, but I felt like I should have came in here to test stuff.
Thank you so much.
All right. So with that, back to questions and answers.
Yeah, that's definitely not malware either. So I would go to that website.
Thanks, guys.
Yeah, thank you.
My first impression is that this badge is very accessible.
Yeah. What do you mean by that?
It's not so steep learning curve to.
No, it's actually, the goal is to kind of, you know, incrementally go up in terms of complexity. There are some that are, I wouldn't say anything's like really that crazy of a vector, but there's the hardest one involves a little bit of effort to get into. But there's some easy ones. I mean, if you just go to the website, you'll get a few of them.
Yeah.
So,
Similar schools. The DEFCON 24 badge.
which one was that? That was the
Was it
that was the
video
Game Boy one?
Yeah,
Yeah.
I think it was an Intercore x86 controller they used.
Oh yeah, I thought they used the RP 2035 or something, the new Raspberry Pi Pico.
I think it was the debut of that chip.
Yeah,
that badge.
yeah. But I don't know, there's a ton of badges at
Yeah.
DEF CON. Did you go to DEF CON? Yeah.
It took me a while to get the console out from that.
Oh, really?
Yeah.
We didn't even mess with it. We were so busy at DEF CON this last year that we didn't mess with it. We had our own badge.
I was gonna say, if you saw the ambulance badge we made for Biohacking Village last year at DEFCON.
Yeah, we made a breathalyzer
It was a
for Las
breathalyzer as
Vegas,
well.
which was fun. It wasn't accurate.
No,
And,
and we had
uh,
to explain that that wasn't a flag, like, don't try to.
Yeah,
decrease
do
your
not try to get the high
to
score.
Unlock the last flag, because that was a real concern. I
Yeah,
had at least.
awesome. Well, I know I ran through that really quickly. I can go back to any slides if anyone had any specific questions, but did y'all have any questions about the badge or the process or anything like that?
I've got one for you. And how,
Sure.
when you're designing like the challenges around it, how
Mhm.
much of it is in your mind sort of getting the balance between software-based challenges
Mm-hmm.
and hardware-based?
Oh, that's a good question. For me, you know, I lean towards doing the hardware side of it. And I think Kyle mentioned it before. It's like hardware is kind of a thing where I think people are kind of weary or scared to venture into hardware because they think it's more complex for whatever reason. So I like the hardware side, and then we just build software on top of it. But you know, the hardware to me and hardware exploitation is really just using a different set of tools. It's kind of the same practice. So just learning these new tools and learning that, you know, there's a tell you guys there's a serial interface on here that basically spits out a flag if you can figure out how to decode the traffic. I see this on like medical devices still in the field. So things like that, I want to make easier for people and then also draw attention to the fact that, hey, probably don't do this on a medical device in production that's like giving life-saving therapy to somebody.
Every single IoT device out there almost has a
Right, and
somewhere
it's default passwords, you know, hard-coded keys, these are all things that are, that's another thing with the badge, is like trying to draw attention to common mistakes that people actually do make.
Yeah, and then going back to accessibility, I mean, the hardware pins that we do have on it, like we try to make it entry level, more beginner, just because, and this is where I come in, because I have to, he's an electrical engineer, you know, I'm the non-electrical engineer, right? So I have to curtail these ideas and making it all hardware hacking for the badge, because I realize that there's different levels to this, right? And you know, he's running a recon shirt for Montreal later this month, right? We're giving an advanced embedded hardware training at that conference, but it's like, it's not fair to apply those same methods to 100, you know, 150 of these to
Mhm.
deter people even more from getting in embedded. Like, we want to make it approachable enough that people are interested and then they can dive in, so.
What is
Awesome.
the best way for people to start interfacing with the badge?
Ooh, that's a good question. So I'll tell you guys now all the tricks. It is broadcasting its own access point. The access point is driven by the MAC address of the Raspberry Pi Pico. So you should all have unique access points. We'll see if that's true or not. So it'll broadcast its own access point, and then the SSID, or I'm sorry, the PSK is actually given to you via Morse code, via an LED on the Raspberry Pi Pico. So after it goes through the boot sequence, you'll see a green LED on the back start blinking. I did give you a Morse code decoder because I'm such a nice person, but that'll give you access to it. So that's the intended way to start interfacing with it. And then once you're connected, it's hosting a web server on, I think it's 192.168.4.1. And then you have the entire web app that you can start messing with. But the secret way that I would start accessing with it, if I was a hardware hacker, would be plug in with a micro USB cable to the Raspberry Pi itself. And then you can interact with it's called REPL, which I think is, I can't remember what it stands for, but it's like a R shell connection. And then you can look at the file system and you can do stuff. You can also do a soft reset if you want to look up how to do that. And then it'll actually print out the password for you. So.
Quick question.
Sure.
Is there built-in safeguards if you have the battery and connected at the same time as you connect?
There's a diode, so you should be okay. I don't know.
Yeah.
Try it. I think you're fine. I don't think it's going to backfeed the way you think it is. Because no, it's not. It's just going to supply more current effectively.
So you can't charge the batteries.
No, you can't charge the batteries. It's expensive
Would
to
be
do.
wise to disconnect the batteries before.
If you want to be like super duper, this is an electro engineer talking. If you want to be super duper safe, you probably should do that. But I think you'll be fine. Yeah. I don't know, we can find out. I don't think I have a micro USB on me.
The opening talk says that we should never assume.
Yeah. Well, I make an educated guess that you might be okay.
For varying large values of maybe.
I've got a board that I'll test it with. We also, I think we have a link to the GitHub. The plan is to just update the README consistently through the day and then just maybe give a few hints on how to access the flags. But I will say there are 9 flags and I did kind of an Avengers Infinity Gauntlet thing. So we've got the Infinity Stones. So your jacket is what this is called. Will light up different colors the more badges you collect. So hopefully I'll see at the end someone's got all the badges. Mine's special because it's actually part of the challenge. That's another thing. There's like a respond aspect of it where you have to go and find. I had duck 1, duck 2, and goose. So I'm duck 1, he's duck 2, and y'all can just go figure out who goose is at some point. But it'll be blinking a different pattern.
And then for the rest of the day, you guys are spending just basically directly.
We will be upstairs. We've got a soldering iron if anyone wants to access the serial port. If they didn't bring their own soldering iron or solder or let's say a logic analyzer. But we've got all that stuff. So if anyone's interested in like decoding signals, we can show you how to do that. Or if you're interested in soldering or tinkering or whatever, or just want to come hang out with us. We're super fun. Just feel free to stop by up there. Yeah.
PCB way, how are the quality assurance?
I haven't had any problems, honestly. The only thing, I mean, now with the tariffs in the US, we had to deal with a little bit of that. So I had to pay duties and taxes on the boards like 7 different times, which was awesome. But no, they've been great. I mean, you can get like 24-hour express delivery and assembly, and I can get like these sample boards I got in a week, which is just insane to me. And then assembly is nice. The only thing with assembly is that you have to deal with sourcing parts. And a lot of times, depending on your experience might be different here, but sometimes you can get parts easier in the US than they can in China in this case. In China, they'll also go and source like, the passive components or the LEDs or something else, because, a lot of times the US provider will just get it from China anyway. So it's cheaper for them to do it, but it's just some lead time to go and source all those components. With this, it's pretty easy, but with a bigger board, it can really take a lot of time. All right. Any other questions? All right, let's see. You want to give any more Easter eggs? I said too
you gave a
much.
lot to those that stuck around, so it'd be fun to.
Y'all make sure and also inspect the content of the web pages as well. That's the last thing I'll say. All right. And then there's also, like I said, the hardest flag to get gives you all the flags inherently, because I don't have a TPM or like a secure element on here. So if you crack the intense one, then you'll get all of them. And I actually, on that badge talk, I had it in there. but I don't think anyone picked up on it. So if that's it, we're gonna run upstairs. Y'all feel free to follow us and we'll turn on that soldering iron and help some people start looking at stuff if y'all want. But awesome. Well, really appreciate the time and yeah, y'all have a great conference.
Thank you very much.
You have sold us Quick and
Oh,
some
you're the
new-
man. Thanks.
some new clippers up there as well. Thank you.
Oh yeah, we also put, there's only 9 challenges, but we didn't spend a lot of time like making it secure. So there might be some more ways to hack this badge. So let us know. Yeah. If you find like a buffer overflow or something somewhere.